Alright, so we are going to start the next unit, and in the next unit we're dealing with the Pythagorean theorem, and in the Pythagorean theorem you're no longer going to be able to give me your answers in decimal form. You're going to actually have to simplify your radicals. This is something that you did learn in algebra, but it's been a little while since then, so we're going to go over how to do it. Alright, so the way I like to do this is I make a factor tree. And with that factor tree, I prefer to use prime numbers. It just makes it easier. Now, do you remember what a prime number is? A prime number is a number whose only factor is 1 and itself. Alright, so go ahead, write these steps down. Factor tree, and so we're going to list some primes. For example, 1 is a prime number. 2 is a prime number, because only 1 times 2 will give you 2. 3 is a prime number, right? 4 doesn't work because 2 times 2 gives you 4. That doesn't work. 5 is good. 7 is good. We got to skip 8 and 9. We also skip 6. We could do 11. 11 will work. And then 13. You get the gist, okay? Alright. Alright, so you're going to circle your pairs. After you make your factor tree, your pairs are going to come out. So they're going to come out from underneath your radicals. So go ahead, next to circle pairs, write the word out. And then you're going to underline everything that's left. Everything that's left is going to stay in. Okay. Alright, so let's go ahead and get our first example out of the way. We are doing the square root of 48. Okay, so 48 is an even number, right? So let's divide by 2. So if I divide by 2, and 2 is a prime number, that makes me happy, I will get 24. Now, I can break down the 24 some more, so let's keep going. 24, let's divide by 2 again. You don't always have to divide by the same number, like I could have, for instance, divided this by 3. Alright, so we get 2, we get 12. We can still break down 12. Okay. So, 2 and 6. And then we can still break down our 6 into 2 and 3. Okay, so I can't break down anything any further. So what I like to do is I rewrite the numbers that are the same all together over here, and I'm going to double check to make sure that I actually did it right. So we have 2 times 2 times 2 times one more 2, and we have a 3. Alright, now the way we can double check is re-plug in your calculator 2 times 2 times 2 times 2 times 3, and it should give you back 48. If it doesn't, you obviously want to fix that before you go any further because you'll get it wrong. Alright, so we have actually 2 pairs, right? Too bad we're not playing poker, right? Alright, so we're going to circle those pairs. Now, from a pair, only 1 is going to come out, alright? And the reason why that happens is because it's a square root, okay? So we're dealing in terms of 2's. So we have 1 2 coming out, and we have another 2 coming out, okay? So we're not going to call that 22. We're going to re-multiply that together. So 2 times 2 is going to give me 4 on the outside. Okay, so I'm getting that because I'm doing 2 times 2 for the outside. Okay. Alright, so what's my leftover? You always are going to stick your leftovers in the fridge. Alright, my leftover is 3. So you're going to make your little radical and put a 3. And radical is just a fancy name for either like a square root, cube root. We don't really do any other ones. We don't even do really cube roots in geometry. Alright, so final answer is 4 square roots of 3. Now, you should never, ever, ever, ever get any of these wrong. If you plug into your calculator the square root of 48, you get an ugly decimal. Let me see what it is. Sorry, I'm just pulling up the... Alright, so it's like 6.9, okay? So, we're just going to write that down, 6.9. And if I plug in 4 times the square root of 3 into my calculator, so you get the same decimal, okay? So really you shouldn't get any of these wrong, right? Okay, so let's go ahead and do the next one. Alright, and I'm actually going to show you a little bit of a shortcut with this one, okay? So, let's go ahead and start out like regular. I'm going to divide by 2. And then if I divide 98 by 2, I get 49. Now, you might be thinking, hey, wait a minute. 49 is a pretty square root, right? What's the square root of 49? It's 7, alright? So that means we're actually going to have 7 come out on the outside, and we're going to have our 2 left over on the inside. Okay, so if you see those perfect squares, watch out for those. Alright, now if you don't see the perfect square, that's okay. No harm, no foul. Break down your 49 into 7 and 7. And then you're going to write your everything in a line. So 2 times 7 times 7. We have a pair of 7s coming out. And they're going to stay on the outside. And your 2 is left on the inside. Okay. Alright, our next example is going to be a little bit crazy. Alright, so for right now, just ignore the 2, okay? So let's break down 18. So we can do 2 and 9, and then, hey, do you see the shortcut? Because 9 is a pretty square root. What's the square root of 9? It's going to be 3, okay? So if we have a 3 coming out, right? So let's just go ahead and finish this. We have a 3 coming out, but I already have something on the outside, right? So if you remember back to the first example where we had 2 sets of 2's coming out, we multiply them together. So if I have a 3 coming out and I already have a 2 on the outside, what is 3 times 2? It's 6, okay? So we're going to multiply our 3 times 2, we'll get 6 on the outside. Take that 2. I didn't really circle it so good. Take that 3. It's going to be 6 for the outside. And then left over, we just have this 2. Beautiful. Alright, go ahead. I want you to pause right here and try example number 4. Example number 4 is a lot like example number 3. Okay, so pause. Alright, so hopefully you had a chance to get example number 4 done. So let's break down 45. Let's do this one by 5. So we 5 times 9 is 45. You can hopefully see your shortcut. The square root of 9 is going to be 3. So I'm going to have a 3 on the outside. I already have 4 on the outside, so since I have 4 and 3 on the outside, 4 times 3 is 12. And then we have our leftover, our 5 on the inside. Alright, now the other thing that we are going to have to do, and this is going to come into play when we deal with special right triangles, is we're going to have to rationalize our denominator. This is pretty much just fancy math speak for saying that you're not allowed to leave any radicals in the denominator. Now remember, denominator is your down number, so it's the bottom of your fraction. Alright, so what we're going to do to cancel out is multiply both the top and the bottom by whatever the radical is in the denominator. Okay, so take a second to copy this down, rationalize the denominator, no radicals in the denominator, and to cancel multiply. Alright, so for our first example, we cannot leave the square root of 3 like that. So what we're going to do is we're going to multiply both the top and the bottom by the square root of 3. Now, the reason why this works is because if you divide, for instance, like 2 divided by 2, you get 1, right? So if you have the same thing at the top and the same thing at the bottom, it's essentially 1. So you're allowed to do this. Alright, So you're going to smush the top. So the 4 is going to jump right in front of the square root of 3. And then the top's done. Alright, now the bottom. So for the bottom part, you're going to multiply by the two numbers that are underneath the radical. Sorry, my dog's barking. Yeah, one of the neighbors just came home. Alright, so you're going to do 3 times 3. So what is 3 times 3? It's 9. Okay, so what is the square root of 9? It's 3. Okay, so you're going to end up with just getting whatever number you had in your denominator without the radical symbol anymore. So 4 square root of 3, all divided by 3. Now, the only other thing that you have to watch out for is, like, let's say I ended up with a 2 at the bottom. I could divide 4 by 2, so you would have to finish simplifying that. But this one, we are done with this one. It's very beautiful, right? All right, let's go ahead and do example number 2. Example number 2 is a little bit more intense, right? So we have what square root at the bottom? 10. All right, so that means we're going to multiply both the top and the bottom by the square root of 10. Okay. All right, so we're going to do 5 times 10, which is going to give me a square root of 50. And we're not actually going to be able to leave that as the square root of 50. We're going to have to simplify it further. That's part of my radical sign. That's not a negative. All right, and then, so we're going to do 10 times 10, which 10 times 10 is 100, right? And then what's the square root of 100? Yep, you get your 10 back. Okay, so we're going to put a 10 at the bottom. All right, so now we need to do our factor tree with our 50. Okay, so I'm going to do that over here off to the side. All right, so I can divide 50 by, let's do 2, and I get 25. Hey, can I take the square root of 25? Yes, I can. All right, so the square root of 25 is going to be 5, right? So that means I'm going to get a 5 on the outside for the top. And I'm going to have that 2 left over on the inside. And it's all going to be divided by 10. All right, now we have to do one more step, I know. 5 divided by 10 is going to be a half. So our final answer is going to be the square root of 2, all divided by 2. Beautiful. Kind of looks like a potato. Okay. We have one more example that we're going to do together, and then we will pause, and you'll do the last one all by yourself. All right, so for example number 3, we have a little bit of a trickiness going on, but we can handle it because we're awesome. All right, so you're going to multiply by the square root of 2, okay? Both the top and the bottom. All right, so the top, you're going to do 18 times 2, which is going to give you at the top the square root of 36. And something should be going off in your head because you can take the square root of 36, right? So we're going to do that in a second. Okay, and then at the bottom, so if I'm doing the square root of 2 times the square root of 2, that's going to be the square root of 4. And then what's the square root of 4? Do this part, it's going to be the square root of 4. The square root of 4 is 2. Okay, so we're just going to have a 2 left over. But we already have a 3 on the outside, right? So we're going to need to multiply this 3 and this 2 to give me 6 at the bottom. Okay, so that's going to go up here to be 6. Okay, so you just told me before that square root of 36 was 6, right? And so if I've got a 6 at the top and a 6 at the bottom, what's 6 divided by 6? Yep, just 1. So this one's pretty. So if you would have plugged this one into your calculator correctly, you got to watch, you know, because we have all those radicals everywhere, you could have gotten 1. All right, so go ahead and pause, and I need you to do example number 4. I should probably put it on the screen first, shouldn't I? All right, pause, and this is example number 4. Okay, so hopefully you got the answer right. Let's see. Alright, so step number 1, multiplied by square root of 6, both the top and the bottom. Okay, so at the top we're going to get 2 in the front. And we're going to do 3 times 6. 3 times 6 is 18. And then at the bottom, 6 times 6 is 36. What's the square root of 36? We're just going to get 6 back. Alright, now we got another problem. 18, square root of 18 is going to be able to be simplified. Okay, so divide by 2. You get 9. Oh, hey, can I take the square root of 9? I can, and the square root of 9 is 3. So I'm taking out a 3, and what do I already have outside? A 2. So what is 3 times 2? 6. Alright, we're going to have 2 left over on the inside. And then our 6 is still at the bottom. And then if you do 6 divided by 6, you're just going to get square root of 2.